So what we'll jump into here is showing you how you can gain confidence in your bolt design, and we're going to do that by using Nastran In-CAD. For those of you that joined us for our last bonus session, we also talked about Nastran In-CAD, and what that is, it's a FEA tool that's embedded into CAD. So it embeds into Inventor. It also embeds into SolidWorks, by the way, in case you're in a multi-CAD environment. And it works under network licensing, so it is flexible and you can share it amongst your team. And it gives you a big range of simulation capabilities. And don't forget that it is Nastran In-CAD, so it's a really well-known and respected FEA tool that's out there. Nastran, which was purchased, NEI software was purchased by Autodesk, I want to say about 2 years ago now. So let's jump into the live demonstration for that. And again, what we're going to do is we're going to go back over to Inventor and take a look at that hub that we were looking at earlier and show you how we can do that right inside of here. So first of all, we're seeing this with the entire bolts and everything, but when it comes to simulation, one of the things I want to definitely clarify is that you don't always necessarily need to have every single part in here. We can represent it in different ways inside of simulation. That's what's going to get us an answer a lot faster and still give us the confidence we need to make sure that this is going to work. So what we'll do here, first of all, is I'm going to leverage this level of detail here where I've simplified this a little bit more. I don't actually have the bolt showing in here, and I'll show you in a moment how we can actually simulate that without having those inside of here. So the first thing we'll do is we'll go to our environments, and in here is Nastran In-CAD. So again, this is an add-on. This is something that can be purchased separately and goes embedded right inside of Inventor once you purchase and install it. So going to Nastran In-CAD is going to take me to a different environment that's very, very similar to Inventor's FEA environment. You'll notice that it kind of works the same way, where you work yourself from left to right to begin a new analysis, edit it, add a material, and constraints and loads. Same concept, those are the things that you need to make sure you have inside of here. So the first thing is, what are the different types of analysis that we can do? Right now we're going to focus on a linear static. We don't have any rubber or plastic parts inside of here, and we don't expect a big displacement at this point. But we can do other things such as fatigue. I mentioned it earlier, if you wanted to do an actual fatigue analysis, and make sure you have some visual clarification of what you're looking at and some values in different areas of the actual design. Thermal stresses you can do through here as well, buckling, and even frequency and vibration. So through here, what we're going to do is we're going to look at the forces that are that make up this design right here. And the first thing we need to do is use the material. And what I'll do for that is I'll import the actual material from the model that's already being used. That way I don't have to specify that. All I have to do is make sure that I actually assign it to the right components. So I'll go ahead and do that right here. Assign it to these two. We see now on the left-hand side there are physical properties to this where we have it assigned. We can always modify this as well. We can go back to it. We can make these nonlinear for large displacement or for different types of material as well. The next part is now we want to constrain this. Where is this locked down by? So we make this fixed, and you see it's a really nice tool here that automatically makes sure that nothing is able to move in the X, Y, and Z or rotate in the X, Y, and Z. So we'll just simply apply a fixed constraint to this center of the hub. And then we're going to apply a load. And the way we're going to apply this load is we're going to pick on these different surfaces here. But we can do this in different methods. We can apply an actual force. We can have a distributed load. We can also give it an actual movement and forced motion, if you will. So we can tell it we want it to spin in this direction. We want it to spin, for this amount of time, etc. So we can do that all inside of here. We can also say, we want to give it its direction by telling it what the magnitude is in the X, Y, and Z, or we can just say normal to the surface of these two. We then give it a total force here, giving it 1,000 newtons, for example, to start off with, and then we can go ahead and click OK. So we now have our material, we have our constraints, we have our loads. What about the bolts? How do we account for that inside of here? What's really great about this tool is that there's something built into here that allows you to select to create these connectors. So in the browser over on the left hand side, I can go to my connectors and create new ones, which allow me to say what type of connector this is going to be. Is it a rod, a cable, a rigid body, or in our case, an actual bolt? What this will do is then allow you to select what type of bolt this is. Is it a cap screw, or just a standard bolt going through? Do we need to preload it? Do we know what the axial preload forces are, or torque for that matter? And then bolt diameter and all this information can be typed in, or some of this will actually be automated. And the way that's automated is I can come over here and say where that bolt is starting, which is on the back end, and then where it ends, where the nut is, over here on this edge. If I rotate this around, you'll actually see that if I zoom in, it's putting in the nut right there actually, and showing you the head of the bolt over on the right hand side. So you don't even have to have the nut bolt washer combo inside of here necessarily, and it's going to pick up the bolt diameter for you. And again, you can type in this information and you can override the materials if necessary as well. One other nice thing about this is, well, I need to do these other bolts over here. So there's a little button right here that allows you to create a duplicate, so you don't have to, close this and start all over again necessarily every single time. All you do is you simply go over to these different selections and be able to identify, well, now I want to start here and end here, and do that for the rest of these as well by just duplicating this pretty easily. Like so. I'll stop right there right now. I'll bring up one where I've already done all 12 of these holes. Let me just bring that up here really quick. One last thing here to do with this one is the meshing. So then we can come over here and give it a global mesh and let it know what the actual size we want for this is. And then if we need to update this or not, we'll get this meshing out of here. But I've taken the liberty of coming over here and creating that for us already. So let me just activate the Nastran In-CAD environment for us right here. All right. So this one has a mesh for us already, as you notice here. So I've already updated this one. We can see it. We can see the loads, where it's constrained, and everything. Let's take a look at the actual results of this. So just in a few minutes here, it'll go ahead and run it. It's, again, I think one of the nice things about this is I don't have to exit Inventor, and you notice right now I could just really easily go back and forth. I went back to my level of detail, right, and I quickly selected my simulation one, so I didn't have to keep messing around or import, export, or anything like that. And again, Nastran is a well-respected solver that exists already, and a lot of times if you're working with anybody that you are trying to maybe outsource this to and they are using Nastran, you can actually give them the code, and they can take that code and they can actually work with it. So that's another big plus to this, is if you're using someone, again, who you're outsourcing to, and they are using Nastran, they can actually pick up this code and run with it as well. So it just really makes it for a much better experience all around, I think, when it comes to using something like Nastran In-CAD. Just give it a couple more minutes here. Shouldn't take too much longer. You'll notice also if I go over the model tree, by the way, you can still see all these connectors. This can help you in identifying, making sure you have each connector, what material you have in here. You can always go back and edit these, by the way, too. So, it's not like you just create this and move forward, and then how do you modify these things? You can still modify them. There's going to be some other tools we'll look at right now as well. Like we're seeing here how many actual elements or pieces it broke it down into, how many nodes, and we can query these things. We can look at these results and be able to see at any point what are the actual values that are happening in there. Anything from displacement to the von Mises as well, different things of that nature. We'll also be able to see how it deforms. I've seen a lot of different examples out there. One that I noticed, for example, one was like a coil, and you are able to actually see that displacement and see how the geometry runs into each other. And you'll see that here too once we have this the simulation run, how we'll actually see that geometry change and move to really see what it would look like exactly. All right. it is complete now. So we'll go ahead and show you how we can look at the different results. So inside of here, we can choose exactly what are the what results we want to look at. So the first thing I'm going to look at here is the solid von Mises actually. By bringing that on here, we can now display it right in our screen, and we can see what the max is at this point. This max will just show you what was the actual maximum result, but then depending on your material, you would know what is the actual max that you can take for this part, or what's acceptable to you. So inside of here, I can change this. For example, let's say if it was 250, so we can see the colors change on here just a little bit better. We'll display that as well, and we'll be able to see where some of our maximum values are at actually. So we can see that right in here. I'll move this over just a bit. I can still rotate and move this part around. I can see my maxes right in this area right here, for example. This node right here. I can also go to my nodes over on the left hand side, and I was mentioning earlier how you can query this display, and what that means is as I hover over the nodes, I'll get a dialog box that shows me what those values actually are, so I can always see that just live right here as I'm looking at the actual 3D part. I mentioned earlier also how you have the option to be able to see how this deforms exactly. So if I go over to my deform options, what that does is it shows me how it's actually going to look in the deform method. And now I can show it as deformed or actually animate this as well. I'll slow it down here just a little bit in case some of you have some lag over the internet here, but you should be seeing here very shortly, if you haven't already, the actual animation of this hub moving left and right. And we're there, we'll be able to see that we do have some tension, some shear going on in this animation. I'll just pause here for a little bit for everyone to actually see that animation. So hopefully everyone's able to see that it's moving back and forth, left and right just a little bit. So we have some shear and some tension going on in there. I'm going to go ahead and stop this animation, and we'll uncheck deform options and be able to go back to my contours here and see different results. So let's take a look at take a look at tension. So I'm going to go to beam, force, AX, and display that. So we can display that, we can see what our maximum values are, and it'll be on the screen as well. Again, I can still query this. Actually, notice query is still on, so I can go to these the axis of the bolt itself and see what those values are inside of here. I can come over here, maybe I want to look at shear instead, so I come over here to AY in the plane 1, for example, and I can see what those maximum values are as well. So again, this gives you a lot more information than what we saw earlier. It was great in the bolted connection that we're able to do a quick calculation based off of formulas that we would typically find in the engineer's handbook. But there's nothing like actually seeing this visually and being able to work with it and make changes, go back, maybe change the bolt diameter size, or maybe change this hub. Maybe we want more holes. But we can now start to explore those different options and be able to see what it is we want to do. Or maybe now we decide we want to do a fatigue analysis instead, or as well, or maybe we need to do a vibration analysis. It gives you a lot more tools, a lot more capability to do things that you perhaps wouldn't have been able to do before. So in summary, we looked at the bolted connection, of course, before, but now we're able to look at using those connectors inside of Nastran In-CAD. I hope you found that useful. For those of you that are already using In-CAD, by all means, please let us know if you have any questions or like to learn more about it. For those of you that aren't using it, let us know. Again, it is a CAD embedded tool, not very expensive, and still gives you the power of a really well-respected tool out there from Nastran. And Nastran can do a whole lot more for you than just this, of course, as we saw in a previous bonus session as well. And of course, as relevant topics come up, we'll also let you know about these types of tools that you can use. Next week's session is creating configurable designs using Inventor iLogic and something else called Configurator 360. So again, I'd like to thank everybody for joining, and we hope to see you on our next session.